Okay, we're going to use Excel to calculate the density of the different coins. You'll notice that the different tabs I've put here, you have the Morgan silver dollar, the Liberty silver dollar, the Eisenhower dollar, the Walking Liberty, pennies, which we're going to have to do in two separate sections because we got the Lincoln, we got the wheat, and then of course this is sheet one that has all the data on it. So we're just going to do it for the Morgan silver dollar, and then what you guys are going to do is you're going to repeat the process for all the others. All right, so what do we need to do? Well, if we want to calculate volume, the first thing we have to do is figure out what the area of the circle is, of the top of the silver dollar, and then we're going to multiply that by the thickness. All right, so what is the formula for area? Well, it's pi r squared. Now what I'm going to do is I'm going to break this problem up into a couple of places. All right, so what I want to do is I'm going to say, okay, well, they're just going to put in pi. And actually, I'm just going to put that number in. All right, so all I have to do is I'm going to actually highlight the whole row here, and it's 3.141, and hit enter. All right, and what I'm going to do is I'm just going to drag that all the way down so that it repeats. 3.141. Boom. Now, in order to get a drag fill, what you do is you actually just click on the lower right hand corner. You get a black arrow, and it will drag that number and fill in that number all the way. All right. Now we need to do radius. Okay. Well, before we can do radius squared, we have to calculate radius. And in order to calculate radius, basically what you have to do is we're going to have to divide this diameter over here in half. All right. So what we're going to do is we're going to do a formula. We're going to say equals the diameter, which in this case is 35.15. All right, and we'll divide that by 2, and that gives us the radius. All right. So again, I want to do this for all of these. Now you notice these guys did not do the Morgan silver dollar. They probably did the half dollar. All right. So what I want to do is I want to drag this formula down. So if you notice up here, it's B2 divided by 2. Well, if we click on the corner, the lower right-hand corner, and get that little black cross, we drag the whole thing down, and what you'll notice, all right, is it fills, and it always does it relative. Okay, this is B28, that's B27. It will do the same formula. Whatever you did in this column, it will do in the next column for this one. All right, so we have radius. Now we're going to do radius squared. All right, now what I want to do is I want that to wrap. As a matter of fact, I want anything in here to wrap. So I'm just going to format the cells, highlight them, format, alignment. Let's wrap the text. Boom. All right. So the radius squared is real simple. All we have to do is take this number, the numbers in this column, and multiply them by themselves. So we're going to type in equals this guy times, and then I'm going to click on that cell again, and that will give me that number squared. All right, and I'm just going to click. Now I'm going to drag that all the way down, and we're going to get that, whatever that number is, we're going to get the radius squared. Okay, so to figure the area, as we've already said, it's pi r squared. So this column is the area of the coin, and it's just simply going to equal pi, 3.141, times r squared, the radius squared, enter. All right, let's drag that all the way down. Now you notice that's a big, hideous, ugly number, and it's got way more digits in it than significant figures. Don't worry about that right now. We're going to fix that when we get to the end. All right, so that's good. Now, in order to figure out the volume, though, once you've got the area of the top of the cylinder, then you have to just simply multiply it by the height, or the thickness, in this case, the thickness of the coin. All right, so the volume okay, and again, Mr. Asconi is the world's worst speller. This equals the area times the thickness. And we hit enter, boom, and we wind up with this number, which is very, very, very close to the number that these guys calculated. So they did a pretty good job calculating volume. All right, some people didn't do quite so good a job. You notice these guys here, All right, their volume is a little bit off. This one here, these guys got 391, we get 392. So most of the people did actually not a bad job doing their calculations. Most of them are rounding errors. Okay, cool. All right, so we've calculated volume. Now, once you have volume, we already measured weight. All you have to do is you're going to divide mass by volume. Now, the only thing I have to do, though, is I'm going to bring these things over so we have a little bit more room to work. All right, and so what we're going to do here is we're going to calculate density. So density, okay, and we're going to just put it in here, density, mass divided by volume. All right, and I'm going to click on that and format the cells and wrap the text. Okay, so density equals mass divided by volume. And what I'm going to do is I'm going to type in, again, this is a formula, so I'm going to type in equals the mass, which is this, backslash divide by volume. And that's our density in grams per cubic millimeter. Okay, so now I'm going to just drag this down all the way. And boom, there you go. All right, so that's how you calculate density. You're going to repeat this process for the 4 that you did. So the Liberty Silver Dollar, if you did that, the Liberty Silver Dollar, the Eisenhower Dollar, pretty much everybody did that. The Walking Liberty half dollar, the pennies, and that will be it. Okay, so that's your job. That's what you're going to be doing. And then when we finally get this, what we're going to do is we're going to compare what we got to what the actual density of these coins actually is.